we're going to mix things up. Instead of doing just a classic roadmap presentation, I thought we'd sort of expose some of the choices we have to make when a technology comes into light, and when it evolves, when it goes through its various communities. And we just wanted an open discussion, kind of expose you to how some of the things are decided and sort of made. With that, the first constraints that we look at as a product management team, and by the way, I run the product management around the CNCF projects here at Red Hat. That spans everything from serverless to the mesh to the multi-cluster management to the security to the Kubernetes core itself. And with me, I have Derek Carr.
Yeah, and I guess I'd be Mike's peer on the engineering side, so I'd be the lead architect for our hybrid platforms engineering org.
So when we get in a room, and you can imagine that room, right? This is an open source company. Literally, there's an idea every minute, and there's an open source project being discovered and being created every minute. And we have employees out there, and we have customers out there in that same ecosystem. We have partners, and they all have ideas coming at us. And when they land on our desk, we're looking at it in three areas. We're looking at it, is it a good technology mix? Does it mesh with existing investments that we have? Will our engineers gravitate to be able to become maintainers in those open source communities? Is the community itself a friendly one to us? Is it diverse? Does it have a lot of participants? Are we going to be the only one? Would we overpower it? Would there be other people involved? And the value is, would it be hard to maintain? Some of these technologies are very complex. Do we have the staff to accomplish that? Will our customers appreciate it enough to put it into that portfolio that they're purchasing from us? So Derek, what are some of the examples of these choices that come to mind when I bring them up?
Yeah, so I mean, I joined Red Hat right at the end of OpenShift v2 when we were starting to look at what was going on in the orchestration space generally. And I think the signals you identified for how we identify stuff was basically what I felt day one when I joined the company. Folks think back in that time, Kubernetes wasn't an idea. We were exploring things like Geard. I think Docker was just getting off the ground. Mesos might have been existing. You had Cloud Foundry. And so I remember probably 3 or 4 months after I was in the company, it was like, hey, should we get involved in this Kubernetes thing, right? And I think at that point it was like, for me as an engineer, very exciting because you get to join a peer company who had a lot of great ideas in the space, and we at Red had a lot of enterprise experience, and form a community from its inception, which was very enriching as an engineer, very impactful, very exhausting. And about a year later, then we had OpenShift 3. Yeah. And I would say whether it's the core orchestration layer, where we evaluated different other orchestration technologies and communities at the time, or whether it's, I feel like these things happen every 12, 18 months. I remember us going through the whole CI/CD GitOps community since evaluating things like Argo and Flux and diversity of technologies. So oftentimes it's like, how can we add value? How can we enrich that community? And then how can we make sure that as you all use the technology, we can take that feedback and move the community in ways that are helpful for everybody. So it's a constant trend.
Those are good examples. Speaking of those examples, when I look at the innovation that's happened in Kubernetes, we're at the cusp of another one that's just about to hit sort of the ecosystem. And it's cluster boundaries. And it's being driven by a lot of different factors, but some of the biggest ones are people having more clusters and people having other people manage their clusters. Now, you've been around in those SIGs for quite some time. What's your feeling around this?
Yeah, I'm curious if we just poll the audience a little bit. How many people run a cluster today? If we were, all right, perfect. How many people run more clusters than they have fingers? All right. How many people run more clusters than they have family members they can name? All right, we'll see you get there. So the journey I've seen with OpenShift and Kubernetes generally is, it's very rewarding for me personally when you are involved in building a technology and people just agree to use it, right? That's awesome. And in the beginning, a lot of people's journeys with Kube and OpenShift generally is let's get that first cluster installed in a given region. And then how do we start getting value in our organization? How do we onboard teams? And if I was to ask the audience today, like how many people run like a namespace as a service model in their company? It's very popular.
Okay, about
a lot of people have value with that. And it's the natural gravity that people follow. As the years have transpired now in this space, you start to get questions, right? Well, what's the overhead to create that first cluster? So today we ask people, okay, we'll get 3 to 5 computers. That could be virtual, bare metal. Assemble together, get a cluster, and then start onboarding teams and grow your nodes horizontally. So the overhead to get that first point of value is pretty well understood. And as an infrastructure team, you isolate your control plane, away from where the workload's running. And you kind of have like the beginning of like a separation of duties within your organization. So how many people have like an infra team and then they're supporting their app teams in their organization? Perfect, yeah. And so, you deploy a CNI to your cluster, you have a big network, everyone's communicating, your teams are coordinating, and you start to run into challenges around maintenance. So like today, it's very easy to incrementally add new tenants to an existing cluster, and eventually you'll say, well, I need HA. I'm going to create another cluster in another region. So now you're dealing with 2, maybe get to 3, maybe get to 5. And I'm curious today, like, do people struggle sometimes with apps that like don't drain gracefully or stall your upgrades or that type of thing? I see some nodding heads, yeah. So this is a very common journey. And right now, like, you start to see these trends and you start to ask, well, what can we do to eliminate these friction points? And so I've seen no shortage of amazing projects where people like partition off apps that fail to upgrade to make sure things can proceed. But one of the things that's been bugging me, and for the last 2 years we've been working on this project called OpenShift. I don't know how many people are familiar with that. But to me, if you consume a product, the cost of that product should go down. Like the overhead of getting another of it should be less. And so this idea that we're exploring right now with OpenShift is, how do we make it as easy as it is for you today to do namespace as a service in your organization, to do potentially cluster as a service? So where you have particular friction points that make it difficult to maybe give out a dedicated or exclusive cluster to a team, what can we do to eliminate them? And then as we explore that space, what other benefits can we provide you? So the OpenShift project is all about running control planes decoupled on a separate management cluster. And this allows you as an infrastructure organization to care and feed for the clusters and the things that you control the uptime of, separate from where the users are running their workloads. So in my head, it's like, how do you make a cluster admin the equivalent of just root on a worker node? But you can't control how the control plane is configured. You can't control necessarily how the operating system is configured. Like, you keep that away from your users, you start to have a separation of concerns. And Mike is aware, we started to hear trends, right? Cube hasn't been very opinionated on how you should deploy it, and that lack of opinionation has allowed a lot of diversity of users and experiences, and has made Cube very vibrant. But we'll start to hear trends where it's like, I need strong network separation between anything that's considered management in my organization and workload in my organization. So we went and said, I remember Mike and I chatting, well, let's make sure that this OpenShift project that we're exploring is exploring that space. So if you need to have like a strong network boundary between your control surface and your workload surface, that's an area where we say, okay, we're going to make that row read different, right? Give you something that's a new piece of value. And so how many people today run more than 3, 4 clusters in a given data center or region? Yeah. So I think if you start to get greater than 3 or 4 in a region, I heavily encourage you to start exploring this technology in the year ahead.
So just to check in, the first one, standalone, is what we all know and what we've all experienced so far. The second one, OpenShift, is to take those control planes, podify them, run them as pods on a management cluster. So you pick an OpenShift cluster as your management cluster. You create namespaces. You launch pods in those namespaces. Those pods happen to be control planes.
Yeah, so basically, instead of you offering namespace as a service to your tenant or workload teams, you basically are now running control planes as a namespace as a service, and then you can just offer dedicated nodes out to your teams. The benefits of this is that the cost of each incremental cluster is cheaper, right? Our target on this is generally, we want to make it sure that you can run an HA OpenShift control plane for about 4 cores and 16 gigs of RAM, right? So if you're running big bare metal servers in your organization, you got 96 cores, 256 gigs of RAM, you don't want to dedicate 3 of those boxes to just running control hosts, right? Sure. This is another theme we'd hear.
And then this next pattern, Edge, what's that about?
So this Edge thing is interesting, right? This caught me by surprise as we were exploring Cube. In the beginning of Cube, a lot of people were against Cube supporting certain types of workloads. Like, it can be distracting. But more and more over the years, we kept hearing, I want to run Cube at the edge. I want to standardize on Cube as my development paradigm, and I want to test in the data center, and then I want to deploy to the edge. So one of the projects that we've kicked off is called MicroShift. And the interesting thing about Edge is you really are talking about like thousands of clusters deployed all across the world, where every region just has, one cluster. And typically, as we started interviewing teams and we start hearing about experiences, there was kind of a unique thing that happened on the edge. Because the set of hardware is very constrained, you ended up having a very strong coupling between the infrastructure team and the app team. Like, they're almost one. And so that kind of informs how we design the product and we think through it in that experience, which is like, how do we make that experience for deployment of your app and an upgrade of the Kubernetes environment at the edge work cohesively together? Those upgrades are often pushed out. They need to be A/B rollbackable. It's an interesting challenge.
Yeah, it is.
Curious, just if we have poll the audience, like, how many people are exploring edge opportunities right now, maybe in the room in the organization?
Yeah, and it's interesting because it's the combination of the control plane with the workloads. And therefore, if you're going to have an HA strategy, you're imposing it outside of the clusters, or you're having multiple single node clusters or compact clusters. So it gets, it's definitely different than standalone, definitely different than HyperShift. And what's this next one, this N-to-1 mean? Yeah,
so these are, the first 3 areas we talked about are areas where I feel like we've chosen to take our engineering investment and our community efforts to get value out to all you now. But we see some other project usage patterns out in the broader community and ecosystem. This next one is around what I kind of call like a virtual clustering technology. So how many people are familiar with maybe the vCluster project in the room? Is anybody? Yeah.
A couple.
So for those who aren't familiar with it, basically the idea is you take a standard Kubernetes cluster, and then you deploy this vCluster solution on top of it, which kind of tries to partition this under cluster.
So you're still in the same cluster that you were on.
Yeah, and so when you start to drill down in this, like, and you start to ask, what's different here, right? So one, the overhead for getting that maybe small control plane is very small, in the same way that, say, our HyperShift effort is. But then when your actual workload is deployed, it's deployed on a shared undercluster. So if you're an enterprise or organization who says, I need strong network segmentation, or I need strong node segmentation, that's where a vCluster maybe kind of differentiates from the space. Now, there's a variety of other projects that have explored this domain, but they all kind of take a different approach to like what level of isolation at what level of the stack they provide. One area that we see is maybe growing in popularity around this space is for folks who need to get a very rapid cluster up for a CI/CD loop, maybe to test an operator, test a CRD, test that type of thing. But I'd be curious if anybody wanted to stop by or talk through maybe if you are using the project, what your experiences are there.
Yeah. So the N-1 means I can have infinite, like a lot of clusters on what used to be one cluster. Yeah. Where HyperShift, there are actually different clusters, different infrastructures even that you could mix in.
Yeah. And so then it's a great way to put it. Basically, I am curious if anyone's exploring the space. Our last row here is we kind of think about what the future would be here. And at Red Hat, we often think, how do we do the right things in the upstream communities to make sure that like the core things we all depend on are still meeting your needs? And there's been no shortage of folks who have been exploring maybe other concepts.
Sure.
But then they often reach this point of like, how much are we willing to change Kubernetes itself to maybe fulfill them? So a number of folks will say things like, I want a higher order of separation in namespaces in Kube than we have today. And really, if that's a need that you all in the audience feel, the best thing to do is to like vocalize that back so we can get the traction and the user interest upstream to see those changes. But I think right now, if we see this space, the top three we talked about are like kind of representative of what we see as real world production usage areas today.
So this last one, the end-to-end concept is, I virtualize the server API, just like I did in the first one, but in this case, I'm also trying to have a lot of different clusters that I'm communicating with. So I have different resource objects that I would have to bring into Kubernetes to control some of that stuff.
And then in general, some of those spaces is where things like Argo CD and stuff are maybe filling needs that kind of vocalize that problem. But it's kind of like, what do you all want Cube to be in the future? If we're coming back, Cube is about to turn 10, right? Maybe a couple years. Like, what would we want it to look like at 20 is maybe the thought process here.
I got to say, I never would have thought this many years into Kubernetes we would have this much innovation happening at such a low-level part of it, the control plane, right? Yeah. You'd think that would be done and moved on, but the use cases are really driving a variety of different ways to install clusters and a variety of different ways to manage them across this location overhead control plane, network node, maintenance, tenancy. So it's definitely something to be aware of. Definitely check out some of these projects and stay in touch. Like, this is a growing area that we definitely need some input. So the next section is a good example of where we have communities that were very focused on solving very specific problems. And then, lo and behold, years later, they find themselves related to one another in some mysterious way. You watched sort of networking grow, especially Ingress grow in Kubernetes, being one of the maintainers up there in the larger project. Can you talk about some of that journey?
Yeah, so if we look at the previous section where we talk about like the wide variety of ways people are deploying clusters, whether it's on small form factor devices, on big servers in the data center, that almost fragmented approach has been very beneficial to the community and beneficial to adoption and vibrancy. Where if we look at the application networking space and what things have been happening now, is a good example of where like that fragmentation that was happening kind of reached this point in the community that says, what can we do to consolidate and get back to like a standard path? So for folks who've been working with OpenShift and Kubernetes for a while, you know, in the beginning, when I first got involved in Cube, it was like 5 resource objects. There wasn't even a way to get ingress into your application. And so we at Red Hat, we had the Route API, and people have been very successful with that, and it's matured. And then we had this effort upstream around ingress, right? And the idea was, well, how can we bring traffic into your cluster and try to standardize it? And at that time, while ingress has been successful, it didn't really meet the mark on portability. Like a lot of people had to go do bespoke annotations for behaviors that weren't yet ready for the upstream to engage. And that time, a number of other, I would say, adjacent communities were exploring networking space. So you had a big revolution in Istio, a big revolution in Envoy, and basically a ton of innovation happening kind of outside of the core of the Kubernetes community. One of the things that has me excited personally is, I think in 2019 now, the last few years have been a bit of a blur for all of us, the upstream community was like, what can we do to try to consolidate this, get everybody kind of working towards one path and get back to maybe the original spirit of the Kubernetes vision, which is how do we ensure portability of your app across ecosystems? And so they started a project called Gateway API, which was originally around this idea of how do we get like an ingress v2 support. And in the last few years, that project has been very vibrant, and a lot of the primitives that you are all using today in routes and using in ingress are being standardized around these concepts of a gateway class, an HTTP route, and a whole host of other innovations. And what has me excited is the implementations for these APIs. While the API is portable, you have a lot of flexibility on how you choose to implement those. And so these adjacent communities that were doing really awesome innovations, you can now choose to implement Gateway API using that technology. So you might use Service Mesh to implement your gateway. You might use a part of Envoy, that type of thing.
No. It's a clever area. When I first saw the Kubernetes Gateway API, the thing that really struck me was the classes. Just like you have storage classes, you're going to have ingress classes. And that opened my ideas towards Canary and some of the qualities I saw in Istio. And now, like, that sort of, in my mind, the problems I was trying to solve started to blend. And then I looked at the Quadrant project, which is sort of bringing a lightweight API management control plane to an Envoy data plane. And then we have all these open source projects that are trying to put little CRs and orchestrate. Once I declare ingress in one cluster, I'll do it in another. Some of our partners in the network space have that ability. And what we're trying to really do at Red Hat now is to just say time out. Could these things have a relationship to each other? Could they all be related to Envoy since they're all building off of Envoy? Could they have CR definitions that, depending on the use case, we add them and that takes you in a different direction? So a lot of really quality innovation on that ingress, egress, and pod to pod. But Submariner and Scupper are an interesting one as well, because those are two technologies that kind of grew up at the same time within Red Hat.
Yeah, one of the interesting things is, for folks who aren't aware, Submariner is basically a project that allows you to have pod-to-pod communication where pods might exist in different clusters. Scupper, for folks who aren't aware, is a project which is basically allowing you as a namespace admin to configure two pods in two different namespaces, maybe on different clusters to communicate. And personally, like as an engineer, Corinna had that chart talking about just how broad the ecosystem is, how hard it is to remember all these projects, even as I'm in front of you all right now in the audience. And one of the things I find really useful is sometimes each project, they might have overlapping concepts, but they're actually serving different teams, right? So like when you have that aha moment with Submariner where you're like, oh, it's actually probably your infrastructure team that's looking to offer multi-cluster pod-to-pod networking as a service to their organization, like Submariner is hitting the mark on that, right? Versus if you have an infrastructure team that's like, I don't want to take on that burden. I'm just not available for it. The application development team may still end up having that need localized, and that's the sweet spot where Scupper is trying to solve. That kind of tension or that trade-off on which team is wanting to provide the value and which team is actually wanting to either consume or need the value, that's a constant thing that we have to deal with when trying to figure out how to position or rationalize these technologies going forward.
Yeah, I mean, Submariner being an IPsec-driven solution at the cluster level, so you have no idea what this cluster is going to be doing in its life. You're handing it over to people. You just want to build it so it has cross-cluster, pod-to-pod communication. Submariner seems like an attractive thing because the tenants don't have to do anything then. And then Scupper is a very specific scalpel. It's based on the Apache Cupid dispatcher project. It requires a route that you would be deploying this controller over on that side and your side, but you get to control that in a non-privileged way as the tenant to the cluster, so very attractive for that. And it's interesting in this talk because it's two different driven use cases by two different personas. One, the sort of user of the cluster, one, the provider of the cluster, both trying to come at the same problem in different points of view.
Yeah.
AI. So this is an interesting one. There's a lot of AI in the press right now, and a lot of people say AI is having its Linux moment. This sort of explosion in people sharing ideas that are just at a very sort of peak. What I find interesting is that all these new technologies will have to run somewhere. They'll have to run on a cluster, and you've been a member of the Node SIG and the architecture SIG, and you're seeing a lot of pressure coming into those because of this innovation cycle we're in. What's interesting to you there?
Yeah, so I've been working on Kubernetes since its inception, and I'm one of the technical leads on the Node SIG, and typically we try to make sure that Kubernetes keeps up with the pace of innovation that happens in Linux. So generally we want to make sure that Kube works great for the broadest set of workloads that might be out there. And so there's stuff like cgroups v2 that just graduated upstream, and you'll see in OpenShift that will make sure things like CPU and memory works even better than it does stay on the platform. But one of our missions in that SIG is to make sure that like Kube is still relevant for the new classes of workloads that come forward. One of the things around AI, I'm curious, how many people are running GPUs in their organization right now? One of the things that has me particularly excited, for folks who may or may not know, there's long been a concept in Cube around device plugins. So you can have, you can advertise a device on a node, and you can say, okay, this node has a GPU, and let me claim it. One of the things that is under development right now that I think is particularly cool is this idea around dynamic resource allocation. So you'll see these two new API primitives coming out of Kubernetes called a resource claim and like a resource claim template. And the idea here is, can we do for devices what Cube did for storage with things like persistent volumes and storage classes? So a lot of these AI workloads, you're training large foundation models, right? You're doing some type of computation. You need access to specialized hardware. And more these days, people are wanting to fractionalize that hardware. I want to have a shared GPU, or my GPU needs to be shared among containers in a pod, or my GPU needs to be shared across 2 pods on the same node. Both those use cases were never possible today with the existing device plugin API. And so what this resource claim concept is doing is it allows you to say, I would like to make a claim on a device. It's a new section on your pod spec. And as the device consumer, you can now start to do things like, I would like to prepare that GPU to run my workload as like a setup step before my pod is executed. I would like to make sure that that GPU is available to all containers in my pod spec. Or I would like to make sure that these 2 pods, co-scheduled together on the same node, can rally on the same device. I think it's going to be kind of crazy what comes out of this. We've been working with some folks around in the community with NVIDIA and Intel around this space, and I'm super excited to see where it goes.
Yeah, I mean, we're doing a lot of projects across the realm of this, right? We've minimized the footprint with our single node OpenShift. I mean, you work to get that thing down to 1 core, hopefully in the coming year, right? Is that coming, hopefully?
Yeah.
The gang schedulers, the secondary schedulers, this wanting to drive your innovation pipeline all the way out to the edge because you want to train your models and get your models out there to execute. And then our multi-cluster topologies with our ACM projects and our open cluster management. So there's just a breadth of value that we're trying to add to that. So conclusion, right? We started to talk about those 3 areas that are constraints. And in the first one, we talked about a lot of the different cluster boundaries, a lot of technology choices. The second one, a lot of dispersed communities starting to come together. The last one, a lot of value we're adding to the platform. But you're working a lot with our partners that want to run services on top of managed services. Yeah. What do you think we're doing? What's the big scope picture here?
Yeah, I mean, so generally, like, the way I look at what I can provide as value to all of you in the room at Red Hat is, Red Hat is somewhat unique in the sense that everything we do is in the open, right? And we have partners that are onboarding on OpenShift to build their SaaS solutions. And you can see a lot of interesting patterns and use cases for people who want to build large-scale technologies on top of Cube. And like, to me, my mission is what I can do to make those proprietary patterns and practices like open to the world, right? So for this year, earlier in the talk, you heard us talk about like how we're getting pushed on a number of like cluster like shapes and sizes and use cases dimensions. So you'll see us around Kubernetes beyond just making sure the community is healthy and working and functional. We're going to do everything we can to make sure that you can get more clusters in a given data center or get more clusters out at an edge and be successful and economical with that. So that's where you'll see us focus on the Hypershift and Microshift and their adjacent upstream projects.
On this list, what's top of my mind is this Stack Rocks. I don't know if a lot of you have tested that open source project, but they went through quite an innovation cycle to become more lightweight and to run as a cloud service itself. They changed some of their persistent storage layer and became more efficient. So I definitely would check out that. They're also doing a lot more with their APIs to allow you to shift left and expose that into the development process. What else do you like on this list?
Yeah, so I've talked to a lot of customers who are running OpenShift in their data center, and then they're also exploring running OpenShift on the cloud, whether that's in Amazon or Azure or name your cloud. And one of the motivations for why they choose to run a cluster in any given region is maybe they'll choose to run in the cloud if their applications need to consume or engage with a SaaS service. So one of the areas that I know we're going to be spending a lot of time focusing on is on what we can do to improve workload identity generally when communicating out to SaaS products. Least privilege is a concern everywhere. Security is first at Red Hat. So what we can do to smooth that experience is an area that I'm excited to see in the year ahead.
Yeah. So we don't have time to go through them all, but definitely a lot of open source here, a lot of community to gravitate towards, to become a member of, to contribute to just voice your concern. We're definitely, Commons is a place to do that, and we're looking forward to talking to you. Thanks, everybody.
Thanks so much.